Welcome to this product video. Today we're going to be looking at the ePMP 2000 Smart Beamforming Antenna. In a wireless network, co-channel interference is typically more damaging to a network than adjacent channel interference. Channel filtering is not possible as the interferer is transmitting on the same channel as the access point. In a typical point-to-multipoint deployment, the AP or base station uses a 90-degree beam width sector antenna for data transmission to and from the subscriber modules. The SMs typically have a narrow beam width of around 15 degrees. This means that if there is a source of co-channel interference in the wide 90-degree sector, SMs may not be necessarily impacted by it in the downlink, as the downlink transmission from the AP is received in the SM's antenna beam width, whereas the interferer may be outside of this azimuth. The diagram here shows 3 subscribers in a 90-degree deployment, and a source of co-channel interference in the sector. The SMs are listening to the AP in their 15-degree beam widths, meaning they are less affected by the co-channel interferer. In the uplink transmission, however, the AP is using its 90-degree antenna to listen for transmission from the SMs. As this angle is wider, the source of co-channel interference in the sector will be having an impact on the uplink transmission, limiting performance. The ePMP Smart Beamforming Antenna was developed to mitigate against this. The 90-degree sector antenna is still used for the downlink transmission from the AP, whilst the Smart Beamforming Antenna is used for the uplink transmission. Smart beamforming creates a narrow, targeted beam to each subscriber the access point wants to listen to when it is time for that subscriber to transmit. By creating a narrow point-to-point-like beam dynamically from the access point to each subscriber in sequence, the access point limits the interference it hears. The beams are created automatically with no user intervention required. There is also no change required to the subscriber modules. This has a dramatic impact on the network performance by limiting the co-channel interference the access point can hear when an SM is transmitting. This diagram shows the effect of an interferer on an SM when it is in the same azimuth. For example, with no co-channel interferer present, the SM is achieving 70 megabits in the uplink. When an interference source is introduced, this drops to 10 megabits. If the interferer was on a different azimuth to the SM in a standard sector deployment, the uplink transmission would still be impacted. With the Smart Beamforming Antenna, the further away in the azimuth the interferer is from the SM, the less the uplink is impacted due to the narrow beam being created for uplink transmission. So how is the uplink beamforming antenna selected in the GUI of the ePMP 2000? In the GUI, there are 3 uplink antenna options to select: auto, forced sector, and forced smart antenna. These can be found in the configuration radio section under antenna options. In auto mode, the AP estimates expected throughput for sector antenna and the beamforming antenna for the current environment, and then selects the better result. In forced sector mode, the sector antenna is used for both downlink and uplink communication. In forced smart antenna mode, the smart antenna is used exclusively for uplink transmission from the SMs. By navigating to the Monitor Wireless tab, you can see the uplink antenna that connected subscriber modules are using. If the SM is using the sector antenna, the antenna selection section will show sector in orange. If the SM is using the Smart Beamforming Antenna, the antenna selection will show the azimuth angle in a vertical and horizontal polarization metric in green. As you can see here, this Force 180 subscriber module is using a Smart Beamforming Antenna for uplink. Thank you for watching.